Good day once more, my dear students. Again here, I would like us to look at a reaction which is referred to as the HOFMANN rearrangement. What is it that actually happens in this reaction? In this reaction, you start off with your primary amide, right? This primary amide, you treat it with bromine in the presence of a strong base, which is your sodium hydroxide, to generate what is referred to as isocyanate. A structure which is referred to as isocyanate, where your carbon atom is double bonded to oxygen and double bonded to nitrogen at the same time. Then this isocyanate is then converted or treated with water to generate what we call a primary amine. So in a nutshell, we move from a primary amide to a primary amine via this intermediate, which is your isocyanate. Now, in terms of the mechanism, how does this reaction actually take place? So what happens in this reaction is that the OH that we have here, it comes in here to pick up this proton. Why does that happen? It's because, remember, with your carbonate chemistry, oxygen is much more electronegative than carbon and therefore has a tendency of pulling electron density towards itself, that is via inductive effect, thus becoming a sigma negative charge, carbon becoming what? A sigma positive charge. The carbon that is electrophilic, that is generated here now, then is fed with the electron density now, like from what? From your nitrogen. Nitrogen like releases its electron density to go and stabilize this positive carbon atom. As nitrogen is doing that, then nitrogen becomes positive, right? This nitrogen now like then takes away the bond pair that it shared with what? With hydrogen. So these hydrogen atoms then become loosely held and can easily be picked up by a base. So this is what happens here now. This is the reason why this OH minus now will come here and pick up this loosely held what? Electrons. Like a proton. So this proton leaves behind the bond pair, right? As a lone pair now, like to what? To nitrogen. Then now like nitrogen will therefore will become a negative charge. It will become negative because it has gained electrons, right? So this negative or anion that we have formed here, it becomes resonance stabilized, right? In this fashion, when these electrons come here to give us what you call like a pi bond, these electrons between carbon and oxygen, then they then move to oxygen. There's your oxygen that is negative charge, and there's your new double bond here. So these are resonance hybrid, what could I structure? These are resonance structures where each is referred to as a resonance hybrid, right? Now, I move now like with this one, like into the next step. Once now like I have generated this anion, this now like ion goes and pick up a bromine atom from a bromine molecule, right? So as electrons come in here, these electrons are repelled to go to the second bromine atom. Then now like here I generate now like a nitrogen bromine bond. In that case, then where the second bromine atom becomes a what you call like now like an ion, in that case bromine negative, right? So once I have this bromine in here now, there is this side is pulling electrons, this side, and bromine is also pulling electrons. So this hydrogen here becomes even more loosely held and can also be picked up by what? By a base. Remember, this takes place in a reaction vessel. So there are so many of these what call like Na pluses and OH minuses like in your reaction vessel. Your OH minus now picks up this proton. So this proton leaves behind the electrons that it shared with what? With hydrogen to generate another anion. Another anion in this case also due to conjugation then becomes resonance stabilized when this negative comes in here, this go out as in the first one. Then we generate a second one, a resonance hybrid structure in that case, right? Now, what then happens now like is that now, if I proceed with this one here, in this case, this now like as it draws back to reform the double bond with your carbon atom, then now like this R group that is bonded to this what we call like carbon atom, it shifts position, it moves, it migrates, right, to the what we call like to the nitrogen atom. As soon as it does that now, like this other bond which was there, right, then is kicked out, so to speak, and then now like those electrons, they go with your bromine to give us another bromine negative. Then in our case now, like we have established a new bond between nitrogen and your alkyl group or your aryl group, and there we've generated a C double bond O. This structure is referred to as isocyanate. This isocyanate is then treated with water. Oxygen is neutral in charge. Then it attacks this carbon atom that has lost electrons to this oxygen. Then this oxygen will become positive in charge. In this case, there's our oxygen with only one lone pair now. There are my hydrogens there. Oxygen is positive in charge. Now, the oxygen that is negative, when it brings back these electrons to reform the double bond, this bond between your carbon and nitrogen, and then it goes out to pick up the the proton from water, and then as this proton leaves behind the bond pair that it shared with water, then to generate an oxygen atom that is neutral. Then now like we've got a new bond to nitrogen now, and then it is to hydrogen, right? So now like this structure now like is referred to as carbamic what we call like acid, right? Then it spontaneously loses carbon dioxide. In this case, in this fashion, where this bond between oxygen and this, it comes in here to form a double bond with carbon. As carbon now loses this bond, which is used to go and pick up this proton, so that we end up with two hydrogens. In that case, this here becomes your primary amine, and then there's your carbon dioxide, which has been lost in that case, right? So this is what we mean by a Hofmann rearrangement. Remember, organic chemistry is easy, organic chemistry is beautiful, organic chemistry is fun, right? And every student, right, can do this thing, right? Do not fear organic chemistry. Do not fear organic chemistry. Do not fear organic chemistry. I'll see you in the next class. Thank you.